We continue Unit 12, Rational Expressions, with the flap covering multiplying rational expressions. When we multiply rational expressions, we need to factor completely and cancel out all common factors. Example 1. The first thing we need to do is multiply across the numerators and multiply across the denominators. And expand the variables. We can see that every one of these numbers have a 2 in common. So I could take out a 2. 2 goes into 8, 4. 2 goes into 14, 7. 2 goes into 26, 13. And 2 goes into 12, 6. At this point, I notice that 2 will go into 4 2 times. 2 goes into 6, 3. We also can tell that there are 3 x's in the numerator and 3 x's in the denominator, and they will reduce. I also see 1 y in the numerator and 1 y in the denominator that will reduce. We clean this up a little bit, and we have 2 times 7 and 3 y's divided by 13 times 3 and no variables. So I end up with 14y cubed divided by 39, and that is my answer. Example 2. The key to all rational expressions is to make sure that you factor first. The target product is -6. The target sum is -1. The two factors that multiply together to give me -6 but combine to give me -1 are -3 and 2. We place these in our box. Ax squared goes in the top left box corner. C goes in the bottom right corner. And the new b's go in the diagonal. Now we take the greatest common factor. The greatest common factor of the first row is x. The greatest common factor of the second row is +1. In the first column, the greatest common factor is 2x. And the second column, the greatest common factor is -3. So these are my factors to this quadratic: 2x minus 3 and x plus 1. In this expression, my greatest common factor is 4x, and I'm left with x plus 1. In the bottom expression, I have an x, and that leaves me with x plus 1. And 2x minus 3 is already reduced as far as it will go. Replace our original expressions with their factors. Notice all of these go in parentheses. Now we see if we can cancel anything out. This 2x minus 3 on top reduces with 2x minus 3 on bottom. X plus 1 on top reduces with x plus 1 on bottom. And this x in the denominator will reduce with this x in the numerator. Our answer is what's left, and that is a 4 times x plus 1. Example 3. We need to factor each of our original expressions. This is the key to rational expressions. In this top expression, I could take out a 4x. This will leave x minus 1. In x squared plus x minus 6, my target product negative 6, the target sum is 1, and those factors that multiply to get negative 6 and add to get 1 are 3 and negative 2. So this will go in the parentheses. In this bottom expression, the target product is negative 3, the target sum is 2, and the numbers that give me negative 3 but combine to give me 2 are 3 and negative 1. And these will go in the factors. And 4x is already factored. So I will replace my original expressions with their factors. Now we notice that 4x will reduce with 4x in the bottom. X minus 1 will reduce with x minus 1 in the bottom. X plus 3 will reduce, and we are left with x minus 2. Example 4. Again, we want to factor the original expressions and reduce. X minus 1 will go away, x plus 2, and the x plus 1. And we are left with x minus 2 over x minus 3. This is the end of the flat multiplying rational expressions.